Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 15, 2025, just yesterday. The big idea is a training-free method that makes drag-based image edit stable by replacing fragile attention, matching with an explicit correspondence map, so full-strength inversion works without test time optimization. The paper is titled LazyDrag, Enabling Stable Drag-Based Editing on Multi-Modal Diffusion Transformers via Explicit Correspondence. And as we will see later, the results are really impressive. Beyond stability, the method unifies precise geometric drags with text guidance, improves inpainting fidelity, supports multi-round move and scale workflows, and outperforms baselines on DragBench with higher drag accuracy and better VIE score. Alright, Figure 1 contrasts stable, drag-based editing with baselines and sketches, how the method works end to end. The figure highlights that explicit correspondence, which means a direct pixel-to-pixel mapping from handle to target, drives precise moves while keeping background identity intact. The top panels compare results on a dog and a person, and the bottom row illustrates a multi-step move and scale workflow that stays coherent across steps. So Figure 2 illustrates why stable, full-strength inversion matters. Stronger inversion preserves identity while letting the text prompt add a new object in the dragged region. The panels show a dog where the drag opens the mouth, and the prompt asks for a red apple. Lower strength misses the object or warps details, while higher strength cleanly places the apple and keeps the background intact. This demonstrates that the method remains controllable because explicit correspondence anchors the move. Alright, Figure 3 presents the full LazyDrag pipeline, which shows how explicit correspondence powers stable drag edits without test time optimization. The left panels trace inversion and sampling, while the middle block generates a correspondence map using winner-takes-all Voronoi regions, so each pixel follows its closest handle. The blue panel details input control that replaces or re-encodes attention tokens, and the yellow panel refines attention outputs with gated blending, which means weighted mixing that decays over time steps. Okay, Table 1 reports the head-to-head numbers on DragBench, and it shows that LazyDrag delivers the best accuracy without test time optimization. Mean distance measures how close the dragged point lands to the target, so lower is better. The method attains the lowest mean distance and the highest VIE score components, which reflect semantic consistency and perceptual quality. Competing methods that require test time optimization trail behind, indicating that correspondence-driven controls are both stable and precise. Wrapping up, two takeaways stand out. Explicit correspondence, not fragile attention similarity, anchors drag so full-strength inversion becomes stable, and correspondence-driven attention controls restore high-fidelity inpainting and let text prompts add new objects coherently. The broader implication is faster, training-free interactive editing that is both precise and generative. Thanks for listening. I am Alex.